Hello students, today we will begin with the chapter haloalkanes and haloarenes, also known as halogen derivative of alkanes and arenes. Here we will understand about following concepts: what is halogen derivative, their classification. Further, we will come to know nomenclature of alkyl halides and also their application in industry as well as in the life. As we have learned in class 11 about alkanes and arenes. Alkanes are saturated aliphatic hydrocarbons. They are represented by the formula CnH2n plus 2. Their common examples are, methane, ethane, propane, butane, and so on. Similarly, you know about arenes. They are aromatic hydrocarbons. The common example of aromatic hydrocarbons is benzene. When one or more hydrogen atom of aliphatic or aromatic hydrocarbon are replaced by corresponding number of halogen atoms like chlorine, bromine or iodine are called haloalkanes or haloarenes. The general formula of this is CnH2n plus 1x. You can see in this reaction. Here, the one hydrogen of aliphatic or aromatic hydrocarbon get replaced by any halogen. It may be chlorine, bromine or iodine. When this gets replaced hydrogen, the compound formed is alkyl halide, or if it is arene or aromatic, then it is called aryl halide. You can see here 3D structure of haloalkanes. See here in this chloromethane, where one chlorine get replaced by hydrogen, or you can say chlorine substituted hydrogen. Here you can see carbon and chlorine bond and 3 hydrogen. Then this compound is chloromethane. Instead of chlorine, it may be any halogen like bromine, iodine and fluorine. Then the general formula for this is halomethane. It is not necessary that there will be only one halogen. It may be 1, 2 or 3. You can see here there are 4 halogens: bromine, chlorine, fluorine and iodine. Then the compound will be bromo, chloro, fluoro, iodomethane. Now, on the basis of number of halogen present in the alkyl halide, it may be classified into monohalogen derivative, dihalogen derivative, trihalogen derivative and tetrahalogen derivative. Now, you can see that classification on the basis of number of halogen present in the compound. See, first one is monohalogen derivative. When in the compound only one hydrogen atom replaced by one halogen atom, then the compound are known as monohalogen derivative of alkanes. See in this example CH3Cl. Only one chlorine replaces one hydrogen and the compound is methyl chloride. This is monohalogen derivative. Similarly, you can see here in this only one hydrogen replaced by bromine. Only one halogen is present in this. Therefore, it is monohalogen derivative. Now, come to dihalogen derivative. The compounds derived from alkanes by replacing two hydrogen atoms by two halogen atoms are known as dihalogen derivative of alkanes. See here CH2Cl2. How many? 2 chlorine replaces 2 hydrogen. Therefore, the compound is methylene dichloride. Methylene dichloride means dihalogen derivative. Similarly, you can see in ethylene dichloride, there 2 chlorine replaces 2 hydrogen. Therefore, the compound is ethylene dichloride. Now, third part, trihalogen derivative. Similarly, in the alkanes, 3 hydrogen atoms replaced by 3 halogen atoms are known as trihalogen derivative of alkanes. Common examples are chloroform, CHCl3. You can see here 3 chlorine replaces 3 hydrogen. Therefore, it is a trihalogen derivative. Another example of trihalogen derivative is CHI3, means iodoform. 3 iodine replaces 3 hydrogen. At the last, tetrahalogen derivative. In this, 4 hydrogen atom in the alkanes replaced by 4 halogen atoms. They are known as tetrahalogen derivative of alkanes. Example, CCl4 means carbon tetrachloride. Here 4 chlorine replaces all the 4 hydrogen of methane. Then it is tetrahalogen derivative. By this, we can conclude that halogen derivatives are of 4 types: monohalogen derivative, dihalogen derivative, trihalogen derivatives, and tetrahalogen derivatives. Now, monohalogen derivatives further classified into 3 types: primary alkyl halide, secondary alkyl halide, tertiary alkyl halide. These alkyl halides are classified into 3 categories on the basis of type of carbon atom to which halogen atom is bonded. Now we come to first primary alkyl halide. A carbon which is bonded with only one other carbon atom or having 2 or 3 hydrogen atom is called as primary carbon atom. In primary alkyl halide, halogen atom is attached to the primary carbon atom. These are normal alkyl halide. See in this example, methyl chloride. There you can see here carbon is attached with 3 other hydrogen and only one hydrogen is replaced by chlorine. But this carbon has how many hydrogen? 3. Means it is a primary carbon. Therefore, this is the example of primary alkyl halide because halogen is attached with that carbon which is primary. Similarly, you can see here in ethyl bromide, bromine is attached with that carbon which is attached with one another carbon, only one carbon and 2 hydrogen. Means this carbon is also primary. This is again an example of primary alkyl halide because bromine is attached with the primary carbon. Now come to secondary alkyl halide. A carbon which is bonded with 2 other carbon atom is known as secondary carbon. See here in the example isopropyl bromide. Here the carbon is attached with 2 other carbon and this is secondary carbon and halogen is attached with the secondary carbon. Therefore, this is known as secondary alkyl halide. So, a carbon which is bonded with 2 other carbon atoms or having only one hydrogen atom is called as secondary carbon atom. In secondary alkyl halides, halogen atom is attached to the secondary carbon atom. Tertiary alkyl halides. In this, a carbon is bonded with 3 other carbon atoms. See in the example, tertiary butyl bromide. Carbon is attached with 3 other carbon. This is tertiary carbon and bromine is attached with this carbon. Therefore, it is an example of tertiary alkyl halide. Hence, a carbon which is bonded with 3 other carbon atoms or having nil hydrogen atom is called as tertiary carbon atom. In tertiary alkyl halide, halogen atom is attached to the tertiary carbon atom. Hence, tertiary butyl bromide is an example of tertiary alkyl halide. Now you can see that monohalogen derivatives are of 3 types: primary alkyl halide, secondary alkyl halide and tertiary alkyl halide. Now we come to the concept of nomenclature of alkyl halides. How we can name them? There are 2 systems of nomenclature of organic compounds. First is common name and second is IUPAC name. Common names are derived by writing the alkyl group followed by name of halide. See in this example CH3Cl. CH3 means methyl group. It is derived from methane, and chlorine means chlorine chloride. So first we have to see alkyl group, which is here is methyl and halogen is chloride. Hence the name is methyl chloride. Similarly, you can say ethyl chloride, propyl chloride, butyl chloride, and also you can say that methyl bromide, ethyl bromide, propyl bromide and so on. Now IUPAC system of nomenclature. You know IUPAC, the full form of IUPAC is International Union of Pure and Applied Chemistry. It has some rules for nomenclature. First rule is we have to find first longest continuous carbon chain containing halogen. You can see here in this example how many carbons are present? 4 carbon. It means this carbon chain contains chlorine also. This is called parent carbon chain. As we know, 4 carbon chain is known as butane. Therefore, the name of this parent chain is butane. Second rule is the position of halogen atom. There is always a minimum number rule, means lowest numbering. You can see in this example 2-chlorobutane. Why it is correct? Because it is on the second position, which is lowest in the, while here you can see that 3-chlorobutane is the wrong one because 2 is lower than the 3. Therefore the correct name is 2-chlorobutane. Always keep it in mind that the numbering should be lower. The position of halogen atom is indicated by minimum number rule, means numbering begins from the end of the chain, which gives lower locant to the carbon atom bonded to halogen atom. Third rule is halogen atom are considered as prefix. As you know, there are how many halogens? Fluorine, chlorine, bromine, iodine. The prefix name of chlorine is chloro. For bromine, bromo, and for iodine, iodo. Now come to fourth rule. The fourth rule is the name should be written in alphabetical order. For example, here the name of this compound is 2-bromo-3-methyl butane, not 3-methyl 2-bromo-butane. Why it is so? Because in alphabetical order B comes first, then the M. Therefore, the correct name is 2-bromo-3-methyl butane. Now, see that some other examples. Here you can see in this slide common and IUPAC name of some alkyl halide. First is CH3Cl. Here is only one carbon. Therefore, the name of this compound is chloromethane and the common name is methyl chloride. Come to second example. How many carbons are here? 3. Therefore, the chain name is propane. And which halogen is present here? Iodine. At which position this iodine is present? At second position. Therefore, the name of this compound is 2-iodopropane and common name is isopropyl iodide. Now come to third example. See that the chain, parent chain containing halogen, how many carbons are here? 1, 2, 3, 4. 4 carbon chain is here. Which halogen is present here? Chlorine. At which position? 1. Therefore, the name is 1-chlorobutane and the common name is N-butyl chloride. Now come to fourth example. See in the picture, how many carbons? Again 4 carbon. Parent chain is butane, but the position of chlorine is at where? Second position. Therefore, the name of this compound is 2-chlorobutane. Is it so? Yes, it is 2-chlorobutane and the common name is secondary butyl chloride. Why it is secondary butyl chloride? Because see, chlorine is attached to that carbon which is attached with another 2 carbon and it has only 1 hydrogen. It is attached with the secondary carbon. Therefore, it is the secondary butyl chloride. Now, next example. How many carbon is here? 3. 1, 2, 3. And chlorine is attached with the first carbon. The name of this, IUPAC name of this compound is 1-chloro-2-methyl-propane. Is it correct? Yes, it is correct because it is in the alphabetical order. Chloro, methyl to C comes first. Therefore, the name is 1-chloro-2-methyl-propane and the common name is isobutyl chloride. Now, next example is, you can see, you have to find the longest chain. 1, 2, 3. Vertically you can see carbon attached with the 3 other carbons. It is secondary or tertiary? Yes, it is tertiary because it is attached with the 3 other carbon. Therefore, it is tertiary. The name of this compound is, common name is tertiary butyl chloride. And longest chain rule say, the name is 2-chloro-2-methyl-propane. Now, I think you know about the concept of how you can name by common nomenclature method or by IUPAC nomenclature. Now, these are some application of alkyl halides in industry as well as in our day-to-day life. Alkyl halides are commonly used as organic solvent in different industries. It is also used as dry cleaning agent, common refrigerants like freon, dichloro, difluoroethane, common antiseptic iodoform CHI3, DDT as an insecticide, commonly used anesthesia, chloroform CHCl3. There are so many other applications. To summarize today's lecture, halogen containing alkanes and arenes are called halogen derivative of alkanes and arenes. Alkyl halides are classified as mono, di and polyhalogen derivatives upon the number of halogens Monohalogen derivative of alkanes are further classified as primary, secondary and tertiary halogen derivatives. By applying rules of common and IUPAC nomenclature, able to name and write different halogen compounds. Now, these are exercise questions for your practice. What are alkyl halides? How are they classified? Write structure of 2-iodo-3-methyl pentane. Next one is 3-chlorohexane. Third question, write IUPAC name of these following structures.